Good morning.
How's it going?
Good, good. I realized I was talking earlier with my mic muted. We've got a big list of pull requests today.
Big crew.
All, what was that? Oh, yeah.
We got a crew today.
It's joining.
Okay. Hmm. Oh, yeah. Okay. Um, all right. The stack streams thing, I honestly haven't been following this at all. Like this is mostly Kifu and Patrick. Um, anyway, looks like it's passing now. It's approved, so it's tagged for QA. Yeah. All good. Let's see the right back stuff from Jason. I haven't looked at those either. Not from Jason, but Jason's reviewing them. Same thing with the messenger threads. That one is tricky. Curious what the status there is. This BlueFS allocation thing, I think I approved this one. It's just being a little bit more aggressive doing the allocation. Um, what's the free cap? So Igor's not so sure. I don't know. We'll see. Um, what else? Priority cache sizing. I just merged that. I think that's the one I just merged. The one I just merged. 25544. Yeah, I just merged that. Keep using the cache if we're will invalidate the cache. I don't know what this is. This is an EC one. It's a bug fix. So I think Nia or Josh, if one of you guys want to review this, this is one of those that the EC cache or op ordering stuff makes my head hurt.
Yeah, you give it read the EC cache code to figure out if that's right or not.
Yeah. Okay. Be great if we had a test case. I hope. Let's see the shared LRU. It needs to be rebased already. 1.4. Oh, this is changes to support Crimson. Yeah, I don't know. I don't know anything about that one. There's a de-ink thing who's reviewing, and this post-arcs buffer. This one was just broken by definition, I think. I'm gonna close it. Okay, closed. A bunch of stuff merged. It looks like the read ahead logic improved. Rough counting improvements. Sampling. I haven't looked at any of the sampling stuff that they're doing, but it looks good. drop allocation tracking, merged, merged, bunch of stuff. PG auto scaling. Anyway, okay, that's all good. And then it's updated. Yeah.
Behind your back, I added your NUMA thing as a performance with a performance tag.
Is that new? The top.
Sorry. Yeah, it's up.
Yeah.
It's like
Yeah.
I'd let you know.
Okay. Yep. I think that's queued up my current batch for testing, so maybe that'll merge today.
Yeah.
If anyone wants to take a look. It doesn't. It's a very narrow case where it tries to automatically pin the OSD. It's only if the network and the storage are both all on the same node. But beyond that, it just gives you a single command that lets you see where all the NUMA status of all the OSDs, and you can set a config option via Ceph config set. That will set it. Much easier to manage.
Can you disable it?
The automatic thing?
Yeah.
Yeah, there's a setting. Yep.
Cool. Excellent. I just realized I should probably ask that.
Yeah. Let's see. There's a de-encode thing that needs to be split. There's atoms. Agio stuff that needs another review, looks like. This pen buffer thing. This looks promising. I think I reviewed an earlier version of this. Take a look. Good. I can't remember what how much faster was it? Quite a bit faster in the micro benchmark. Good. Yep. I guess that's mostly it. Bunch of old stuff here.
How long do we let stuff sit before we close it? Automatically?
the automatic thing. It doesn't automatically closing it, it's commenting on them. We should probably take another pass over the stale tagged request before we turn it all the way on and start closing stuff. Maybe right after Nautilus is out.
Yeah.
Anyway, okay. We're going to talk about RocksDB sharding.
Yeah, Adam, you want to take us away?
Sure. RocksDB sharding. Hello. Okay, RocksDB sharding is done specifically as a targeted solution for sharding RocksDB for implementation in BlueStore. It means that it will only be able to handle one letter prefixes as used in BlueStore. It's designed in a decorator way, meaning that only interaction with BlueStore code is on initialization when you have to initialize KV database, decorator database with a RocksDB database that you open. I'm currently on a stage of cleaning up unit tests for this, and I expect that after that step there will be no problems with adapting it to BlueStore. There are, however, limitations because this sharding RocksDB in this attempt is only for splitting for multiple column families, which means that we expect to have a reduced latency when we do compaction. We expect, at least I expect, minimized impact for stalls. And this is not in any way a solution to have multiple RocksDB databases working together to provide data to BlueStore. And that's the status. Yep, that's it.
What happens if you have a transaction that you're building and you try to modify things that are in two different shards that just sort of turn into two transactions? Make it.
No, the good thing is that RocksDB internals are perfectly fine to write simultaneously to multiple column
Oh,
files.
right. This is just sharding across column. Oh, nice. Got it. Okay. Is it how far away is it from?
Multiple databases
Yeah, it
will
would be much harder.
another task.
Yep.
Yeah.
So
How far it is?
from
Well,
being able to
I just
like a benchmark and actually get a sense of whether it's helping or not. That's the.
like next week, definitely. Not tomorrow, but it's like I was able to make first batch of operations, and the other ones are just like the same pattern. So there will be problems, but it should not be too long. Next week.
Adam, once you're at the point of doing that, I've got a handy tool that can go and like aggregate the compaction stats from the OSD log. So if you try it like both with and without your PR, we can see if it changes any of the behaviors.
Cool. Thank you.
All right.
Cool. Okay.
So we've got Radek, and I thought I saw Kifu earlier, but maybe he didn't make it. Radek, do you want to talk a little bit about what you guys are planning on doing in the C-Star group?
Let me try. Let me try from seeing about the requirement, about the scope as I perceive it. The primary idea of the first stage of the Crimson project is to verify some assumptions we made about the C-Star. Basically, the assumption it will significantly help in the domain of performance. That's the critical. That's the absolutely critical thing, and we would love to have the verification as quickly as possible. We want to verify our assumptions or fail early. The absolutely worst scenario I see is burning a year of the whole team work, conduct and merge multiple changes, the Rados infrastructure, maybe even alter the protocol itself, make yet another branch, yet another round of C-Star modification, and they say, oops, it doesn't work. That's one of the reasons why the extremely simplified design is, in our understanding, the best way to go. However, I would also want to point out that simplicity of implementation usually translates into simplicity in maintenance. Easiness of maintenance, reduced costs, reduced number of bugs. Especially, for me, it's the key. Simplicity is the key feature design of what we are doing in Crimson. Because, at least I don't perceive this project as the user space thing. More, I'm putting even more. I guess it will be more like kernel level programming than the current user space coding we have in OSD, in Ceph-OSD. So I'm pretty sure we will have to do with a lot of problems, and spending complexity. It's a cost. It's money. Spending complexity for at the very beginning of the project, it's not the preferred way to go. I am afraid that the growth of complexity never stops, except from some restarts like we are doing right now. I expect the things will become even more complex in the future. So I would love that from something maybe not simple, maybe even dumb. And I see some possibilities to reduce the initial complexity we have right now, without maybe even without affecting the flexibility. At the moment, on the Ceph mailing list, we have some discussion and some good points about lack of flexibility in the proposed design. I think it can be yet another red herring. Sage has pointed one last time. But Mark, you asked an extremely good question about our understanding of the OSD concept. And I guess everybody has different. Yeah. So let me share a link. It's basically a first part of my response to very good points made by Matt Benjamin. I apologize for not sending it before the meeting. I asked myself 3 questions to refine my understanding of the OSD concept. And from my understanding, OSD ends at the object store interface. So saying I want to have an OSD incarnation, an OSD concept, sorry, not incarnation, OSD concept living on single core actually says nothing how the object store is being implemented. Even now, in the Crimson group, we are thinking about alien adapter. Idea is to be able to consume existing object store implementations like BlueStore all together with the OSD, with the new OSD. And we will have, in that particular object store implementation, we will have a thread pool. Thread pool can mean one thread, but also can mean many threads. And it's from the beginning of the proposed design. Multiple threads translate into multiple cores, possibly. So I perceive that we still preserve the flexibility in the matter of how much cores the physical incarnation, not the OSD concept I'm writing all the time, a physical incarnation of it. I mean, /usr/bin crimson-OSD. Basically a combination of the object of the OSD concept with concrete object store implementation. It will be able to consume multiple cores. However, it won't be enforced whether to consume multiple cores or just one it will be a matter of private implement. It will be a matter of implementation detail of particular object store interface. That's the key part. So I can imagine a design where we do the sharding at the level of object store, and this might be extremely important format, I guess. Let me share some notes I made last night. There is a sketch of a decorator, sharding decorator that implements the futurized object store. Futurized object store is basically, well, we can think about it just like object store. It's basically a conversion from returning integer to future integer or some future buffer, something like that. Very simple thing. The mentioned Matt Benjamin yesterday has pointed out some very interesting deployment scenarios. I assumed that we have a lot of capacity available in the current RAIDOS layer implementation, that we can deploy many OSDs, and we know from the 10K testing it's possible. But Matt has pointed out that there are some hardware configurations that drives limitations much lower, especially for the limitation of the number of connections. I think that well, we have this limitation even now with the current design. Addressing it's concept about the problem number 2 I decomposed yesterday. Capacity of the RAIDOS layer, and it's different problem from the one we are targeting in Crimson OSD. Crimson OSD is about how to efficiently consume very fast devices. However, between those two problems, we have a junction point, because design of the object store, design of the OSD can increase or decrease the demand on RAIDOS capacity. And I guess that's decreasing, lowering the demand for the number of OSDs, for the number of leaves in the crash hierarchy, is one of the deployment hacks our deployment engineers are using when dealing with such hardware. And please don't understand those words in the blunt meaning. Hack can be pretty acceptable right now. We know that there is at least one solution increasing the RAIDOS, addressing this limitation of RAIDOS capacity, increasing the number of connections we can have in a cluster. It could be going stateless, but it's a big change. So I personally think that our deployers, our deployment engineers are fighting with the problem by massive aggregation of disks, like some kind of software RAID. I'm putting multiple disks inside a RAID, and on output, I'm getting one physical device. I'm deploying with USR bin Ceph OSD on. This allows me to have less connections in the cluster. And I think that Mats and maybe Greg are thinking that the whole new physical USR bin Crimson OSD will be limited to one core only, which translates into inability to use those deployment hacks anymore. I think it's not true. I think we can have these hacks still available. But we want that. I also think that we don't need to be affected by having the crossbar at the network layer, at the messenger layer. We could have it basically put as a private implementation detail of, let's call it, I know it's better naming name needed. Let's call it sharding decorator or new object store or something like that. The biggest win I see here is that it's not obligatory. It's interchangeable with some very simple, extremely simple implementations of object store concept, like futurized mem store or maybe futurized pet store, whatever. Multiple possibilities are there.
Right. So did I understand what you were saying, that you'd propose that you have kind of a one-to-one mapping of OSD to object store, but shard within the object store? Is that right? Did I understand?
Yes, exactly.
Okay.
Yeah, I mean that's basically what we're thinking before. The difference here is that we're also sort of making the assumption that it's going to be, for now, one core servicing that.
Yeah.
It could be, but it's not enforced to be. That's the key difference.
Yeah.
We would have one single messenger that can be reused by multiple object store implementations, but the forking part would be abstracted by only one instance of object store.
And you'd always have one instance of a messenger per OSD, never more?
Well, it will be multiple because we need to connect to multiple things.
Because you have the front interface and the cluster interface, and is that what you mean, or
something like that?
Yeah, but
okay.
that'll be on one core. I'm just really excited about anything that will sort of speed us along to the point where we can actually stand something up and get some sense of how it's going to perform. Even with Memstore, I want to know how quickly we can shuffle requests on and off the network and do some like request processing, so that we can have a more informed decision about the rest of it. But I don't know whether we're going to be able to like drive a fast NVMe with one core. Is it still going to be like 3 cores per NVMe? Is it going to be like 2 NVMEs per core? I have no idea, really. I know that we are wasting a ton of time right now with all of our reference counting and thread pools and all this, whatever. The current code is like so much bloat and overhead. So I really want to find out what sort of a minimal stack, how fast we can make it go. So that we can
agree, Sage.
And that's
drive our next.
If we don't do any kind of, like in the prototype, if we don't do any kind of like backfill or recovery at all, that will by itself will like eliminate a bunch of stuff. But,
right. Yeah.
But not on hot paths. We
Yeah,
are
no,
interested mostly on the hot path performance.
Yeah.
That's the goal, the principal goal of the first stage of Crimson project, to prove our assumptions or fail early, not after a year from now.
Yeah. What I'm saying though is, for your initial test, yes, if you're right, if it's on reads, I think you're right. If you're testing writes, as soon as you add that back in, you're going to have a huge difference. You're going to
that'll probably be phase 2, would be to implement replication, so that we can see what replicated write it looks like.
Yeah, I would. Yeah.
I'd say phase 1 is probably read and write, no replication, just to like get the request in and out. Phase 2 add replication, see what it writes.
Guys, I'm a bit afraid about. Well, I'm really afraid about the complexity because I think we are going to do self-bedded things. Self-bedded is something like it's connection. It's a junction between embedded techniques like user space drivers, lack of isolation, shared address space between all the things connected all together with very, very, very powerful and complex CPUs and other devices. That's the reason that I desire very simplified design.
Yeah.
I'm afraid we are doing to make basically a kernel.
Yep.
Yeah.
From that standpoint, from the complexity requirement, well, I'm more about putting requirements for the complexity level, for the complexity limitation, from kernel than from user space applications. And unfortunately, the sharding at the messenger level, it's complex. And I'm also afraid it would require modifications to C-star project to even do that correctly. I shared a link. We had on Tuesday on the Ceph Devel IRC channel, we had a good conversation about some possibilities to address the thing. It was the continuation of the discussion in comments. Kifus has sent an email to a letter to the discussion. But I just wanted to share the original document that drove it.
Yeah. Yep. Okay.
Well, so Tushar, can I pick on you a little bit? You're here from Intel, and you've got a bunch of folks working on different things that are all kind of in different varying capacities related to all of this. Any opinions or thoughts? Maybe we don't have Tushar.
Isn't he still in Hawaii this week? Something like that?
Yeah, he might.
Okay.
Maybe he's on the beach and listening in.
Yeah, I mean, it seems to me like goal is still to just move quickly and get to a prototype, and we'll find out. We'll know more about what we need to do.
Yeah, I think the plan to fail fast is really good, right? Like, try it and just see what happens, and maybe it works amazingly well, and then we have to make more decisions about if there are costs that we don't know about. But if it doesn't work well, then at least we know that.
Yeah, exactly.
Exactly. If we have to fail, let's fail as early as possible.
Yeah, from that standpoint, I think you guys are definitely, especially since this is the easiest way to go, right? And you might as well try it.
Yeah.
The most stupid way I can imagine about.
Hey, Mark, Sage, can you guys hear me now?
Oh, there you are. Yep.
Yes.
Gone.
Oh, sorry guys. I was actually connected to the Intel VPN and it drops me off all the time. Sorry. So yeah. So yeah, I was hoping that Yingxin, Radek, through the discussions that are ongoing, we can have something that's testable, like in maybe in the next couple of months, right? That was my hope. And so Mark, your question was also on the SPDK side, or because we have folks working on, of course, the C star messenger front, which is Yingxin and Chinmay, and we also have on the SPDK side, we have quite a bit of know-how on having worked not any stacks that would involve replication, but at least we have converted from, let's say, legacy iSCSI, and in some cases stacks that don't do as much as Ceph does, but we know how to do maximize, for example, all of the NVMe IOs with a finite set of cores, maybe, and how to do the threading model right, essentially, right? So we have some expertise there. So which part were you referring to, Mark, like when you asked that question?
So Tushar, I think the thing that came up last week that at least for me is something I'd want to understand better is if we kind of go down this model of having lots of kind of single core independent OSDs or shards or whatever you want to call them, I don't know, that are all talking potentially to the same storage device, and SPDK is involved. What's our route? Like, what's the best way for us to do that? And what should we be thinking about, as we go down that path? How should these things talk to the hardware?
Yeah. So there are actually multiple, different stacks. In different stacks, we have used different approaches. We have had a pipeline model where you have a shared, the cores basically use a shared lockless data structure, like very much DPDK style, right? Where multiple cores are, you have, let's say, one acceptor thread, for doing your network processing, core 0, and then the other cores are just handling the submission and completion queues, for example, right? So we basically have been doing this mainly a pull model, where like one core submits work and the other cores are simply basically workers. They take work and put it back in the completion queue, which there are other set of threads that consume, right, essentially. So there's that cooperative model, and in some cases we've also done run to completion sort of models on threads. So this is something I still need to think about, but maybe but we have basically done both approaches, and all of these examples are actually, like, they're already upstream in SPDK. So Mark, I mean, perhaps what we could do is maybe have let's see, either there's somebody from the SPDK team or Yingxin Radek and us, some of, like, talk about this in detail next week when I'm back in the States, or back in mainland, I would say. Yeah, because I'm, like Sage mentioned, I'm actually still in Maui. I'm not in mainland yet. Sorry. But yeah.
No, we're sorry for picking on you.
No. But my point is that both. So we have. And again, Radek, I don't know if this follows kind of what you what you were describing earlier, right? When you say single core OSD, you're talking about, still talking about multiple threads for OSD, or
possibly, but we are not enforced that way. We can have an object store implementation using only and the same thread as the whole OSD concept, or we have an object store implementation using multiple threads, multiple cores at the same time. Still, I guess the most C-star way, it would be the first solution.
Single thread, single reactor, right?
Exactly. And object store implementation being executed the same reactor, the same place, the same thread, without spawning its own threads. But it would be still possible.
Okay. Got it. So, so yeah, and when you said you want to do this contained, test contained exercise where you want to implement something, so would that be? I mean, I was actually thinking about whether we could use something that exists in SPDK as a.
Let me provide more details on that.
Sure.
The first testing step, the first testing milestone would be basically abstracted from the storage or any kind of storage. We plan to use futurized memstore, basically a memstore implementation that can live inside rest of the Crimson OSD, inside the same reactor as the OSD concept thing. So we will mostly test the network side. We'll stress very hardly the network layer. The storage won't be used at all. Testing it would require very simple object store implementation. Basically, maybe an extension of MEMS or something like that. Pet store, let's say.
Yeah. So Radek, I'm actually not referring to the NVMe block dev, right? In SPDK, that part at all. I'm actually just referring to the threading model. I mean, and maybe I shouldn't use the word SPDK. This is just strictly, user space pulled threading model example that these development kits provide, right? So let me think about this some more, as to which stack can we use, because I know, like, for example, like Ali, they implemented their own, like, an entire object store based on SPDK, over the last year or two. Of course, it's not upstream, but there are actually some other examples that are part of SPDK now that are, that may serve as a good guideline as to which threading model works the best for us to scale, right? So Radek, I don't know, have you looked at the NVMe fabrics or the iSCSI targets, the way they implement networking? And I can actually walk you through some of that, like in detail next week. But have you looked at those already, like, as to the threading model part of it?
Not yet.
Okay. Yeah. So I would actually highly recommend doing that, and I'll see if I have any drawings I can share with you. We have some architecture and flow diagrams. I'll share those with you. If you're looking to do some just a contained exercise where you just looking at chatted messenger, and how to best use the core listed you have, that may be a good starting point to see if we can extend from what we've already learned, right? With SPDK. So.
Tushar, would there be a reason why you wouldn't want to use SRIOV or vhost block or any of these other things to split things up and have each almost like independent processes all targeting the same hardware?
Yeah, so SRIOV, and actually to say just question, namespaces or NVM sets, these features are not, they're not ubiquitous yet. Right? I mean, SRIOV is in the NVMe spec, but most implementations of NVMe are not going to have it until for a couple of years now, I would say. So, and then in terms of namespaces, we may get, in some cases, we're going to have, let's say, four namespaces per device, which may be too small. I mean, we are always going to be limited by, by the number on the one end or the other. And then NVM sets is still very futuristic, right? So I was thinking we may need to, I mean, we may not be able to make any assumptions on, what support we get from the hardware side. Yeah.
So it sounds kind of like what we would probably end up targeting initially then would be, if we do need multiple cores to keep an NVM busy, then we might have like 4 OSDs, each running primarily in their own thread on their own core. But when they actually go to do IO, they're using this lockless queue, and then there's one other core that's just driving the IO.
Essentially, yeah. That's the threading model I was describing. Yeah. More of a pipeline kind of model. Yeah. And in terms of the vhost block, Mark, that's something that has come up over the last year quite a bit since we put it out there. But I'm actually not entirely sure, because vhost is so specific to QEMU based implementations that I don't know, like how we whether we want to marry that right on the OST side at all, like. But that's something I actually don't know. Like Ben said, right? Ben Walker said, Mark, last week. We may not be able to use vhost as it, but something similar. But in general, though, I like Sage described, right? I think it's probably the threading model that's going to work for us. That's the best. We may not be able to make a lot of assumptions and bring in virtualization. We may, yeah, right.
Am I correct that I can see the SR IOV like multiple multiple process access the same device with very good isolation? I can recall our discussions at the QAT when I was at Mirantis.
Yeah.
Basically, those devices, QAT cards, were able to be handled very efficiently from multiple processes at the same time. The problem there was just having not good isolation, but it seems that it's going to be addressed with SRIOV. Still, to have multiple processes consuming the same device, SRIV, it's a good extension, but it's not the essential thing. Am I correct?
Yeah, I would say it will be a good optimization. It will provide a good optimization opportunity, in step 2, for example, but we may not be able to make that assumption that we'll have it always. And I can actually provide a looking at the roadmap, like on the Intel side, Intel and NVMe side, I can definitely provide us a definitive timeline as to like when and what drives it will be available in. But I'm pretty sure we'll find folks that may not want to use SRIV for manageability reasons. Like if you know, in the cloud, particularly in the networking space, a lot of people actually don't like SRIV because of VM migration related challenges, right? So they don't use SRIV at all. So you're going to find examples where the same thing applies to NVMe space, where people may not want to use it. So we may want to look at it as a second step optimization. Does that make sense?
I'm not assuming we have IOMMU. We will have IOMMU on the board.
Right. We may not be able to assume that always.
We are going self-bedded.
Say that again. Sorry, you broke up.
We are going to use some embedded techniques in the server environment. One of the reasons why I want to keep the design very simple.
Yeah.
Drivers in user space, maybe not with the best possible isolation.
So Radic, in your world, does the having kind of the I guess it'd be the object stores be kind of almost like worker threads that are then sending data to a particular core that's actually doing the writes? Does that still kind of make sense in that world for
I
you?
think so. It's it would be hidden from the OSD concept. It will be implementation detail of object store.
Okay, I want to push back on this, Radic, and maybe I'm just not understanding what you're saying, but it really sounds like basically what you're saying is I don't want to do it now, but in the future we probably will do all the same things that we're having trouble with now. And that's an argument you can make, but I'm not sure if that's what you're actually making, or like I don't understand how it's simpler to put it in the object store than at the messenger.
Greg, I don't know which model is the best. And it could be the best one is have everything served by the same physical core, from the network from the network to the management till the disk itself. Of course, it has some limitations, possibly needing a lot of cores to saturate OSD. To saturate physical device. This means we would be doing partitioning basically. However, it might be also that we'll need to do aggregation, at least for some cases. But still, I'm pointing out that the partitioning doesn't need the crossbar. Aggregation does. And we don't need to enforce the crossbar for all futures we will have. All possible futures we will have. That's the key part of the design.
Greg, what? Oh, sorry, Radic. Do you have more you wanted to say?
Well, I'm just afraid that if we make the crossbar obligatory for all object store implementations, we will end up introducing extension to the radius, allowing to bypass the cross.
Well, I
Greg,
don't think that. Just because we have the ability for a crossbar, that doesn't mean it's actually doesn't mean there's actually any code there that does it. If we're just down to a single core, because all the futures collapse.
Yes, that would be the best. That's the reason why I'm thinking about putting the crossbar as a private implementation detail of particular object store. If we need to use it, we can have an universal sharding object store implementation.
But I mean, that argument applies to a messenger crossbar too. So the difference is whether or not we want to do an upfront design that lets us shard, or whether we lock ourselves into a future where very little of our code can apply if we have to introduce a messenger crossbar.
Greg, what I was going to say earlier, that I don't know if this is exactly Radic's point or not, but when I was playing around with MemStore and looking at BlueStore and FileStore, it felt like the object store interface really forces you into a very specific kind of design right now. Like what Radic is describing to me feels like it would be much more flexible in terms of how you implement object stores, if that makes any sense.
Another benefit, the not obligatory crossbar would sit deeply in our own territory, very far away from the border with C-star. And we found during implementation of sharded messenger that C-star might be pretty incompliant with what we would need to do to have the sharding there. for instance, C star, and just as a result of DPDK, wants to determine the core a connection will live on. With the sharded messenger trie, we wanted to do Crimson OSD, being able to determine this mapping. But we cannot do without modifying
Is that really the only reason that you've been pushing this single core concept?
Not only, it's much easier and much weaker when it comes to having something testable. You don't need to share messenger at all. You can re-grab the mem store, put it into the same thread, absolutely the same thread as the rest of the physical Crimson Dash OSD, and will be fine. I know that memstore has some locks. First of all, first approach is just to ignore. Maybe they won't be contented. But let's prepare ourselves. They will be, and try to consider. We know that in the perfect single thread design, we can have Ceph atomic wrapper. For non-C-star world, well, you can apply it with set, just running set on the wall Ceph3. For the non-C-star world, it would map to STD atomic. But for the C-star single-threaded Crimson OSD, it would be plain operation without any locked prefix or something like that. Okay, this deals with simple atomics, but we know we have even more complicated locking primitives, locking structures in memstore. But please recall that C-star is basically a voluntary preempting scheduler for user space. It means that your code can be preempted only in some preemption points. And those points basically are I/O, or jumping between two continuations, two lambdas of C. In memstore, I think we don't have anything like that. So it could mean that in addition to the Ceph atomic, we could have also Ceph C-star. In other words, we can just remove all locks from memstore and use it. That's very nice thing, I guess, because it allows us just implement, well, Messenger is already implemented. It will just allows us to implement some read path details, have a testable Crimson OSD. And then, after the testing, if it's fine, we'll need to think more about object store. It might be we'll need to take into consideration the details of SPDK or other thing like that. I mean, the storage stack. Might find the best idea to consume is like with the memstore, from the same thread as the messenger lives on. But we are not enforced to do that. We still, well, we will consume Bluestore using thread pool with the same design. And for Matt and our deployment engineers, needing.
I mean, so the fact that it makes it easier to use memstore is like nice, and that's a checkpoint for evaluation, which you're right, like being able to evaluate stuff is important, but like the ability to use memstore nicely isn't a long-term design consideration.
Because the long term is pet store.
And
It will be.
and
It might be
sounds like
pretty
what you're
similar.
thinking is that okay, so we can like shard up the object store implementation, and that's nice if all of our CPU time is spent in the object store, but that's not true, I don't think. So I'm just like, I mean, we run object classes, and those all run inside the OSD, not inside the object store. And some of those, I mean, they're usually cheap, but not always. And
Well,
we
there's
do
erasure
keep
coding. I
things
think
in-
that's probably the bigger. That's the bit I'm more concerned about sending CPU time.
The what?
The erasure coding,
Oh, yeah.
like even you imagine like the fastest possible situation, you're still going to be like processing a lot of data.
Yeah.
Might not fit on the core.
And so I'm just,
So
I haven't assimilated your third gist about the assertion with the C star atomic or whatever, because that's complicated and we're talking. But if our main thing here is that we feel like we're fighting in the messenger layer against C star, maybe we should look again at what we're doing with our messenger layer, not say let's not do it. Like there are lots of ways to do a crossbar, and maybe one of them doesn't work very nicely in C star, but the others do. Like I don't think it's nice if we can control the core pinning, but I don't think it actually is going to matter that much because, most things that connect to an OSD are going to talk to a lot of different pieces. So if we connect to the first, like if we try and pin their connection to the object that they first happen to talk to, that's not really an optimization. And it could be that we just want to allocate a core to be the messenger core, and that's responsible for sending the messages out to the others. That's another model that I think works. Like there are lots of ways we can go here that ought to work nicely with C star, and that
I think the sooner we have code that will run, then the sooner we'll be able to make intelligent choices.
Yeah, and
anything that gets us quicker there.
That is a powerful argument for a single core model. My concern is that we can get there and have code that runs there, but
I think it's a prototype. It's not gonna. There's gonna be so much that needs to be changed in all of this. It's not like we're gonna write this code once for the prototype and then we're never gonna touch it again. It's gonna be evolving. It's gonna be like a super stripped down, simplified I/O path. The sooner we know, the sooner we'll know what it should look like.
I think as long as we go into it with that attitude,
if we explicitly think that we're going to change 80% of the code anyway, then fine. Why are we even bothering to talk about it? But
yeah, and that's the reason why the simplicity is so nicely. It's so nice. It's so pricey at this point. I don't think that it's one timer implementing this thing. Those crossbar driven things are one timer. We will have to do with them a lot. And they are complex. So maybe starting without them and adding later, if it's absolutely necessary, maybe that's the way to go.
Well, see, that's the part that scares me is from where I'm standing, most of the code shouldn't care what the crossbar is. It should just have some alias type for, connection references or connections and messages and things, and that can be whatever we want as we change it. We just need to have the workflow in place at the top end that lets us do a crossbar if we need it.
At the moment, you are talking about some of the methods to deal with increased complexity. You are talking about the black box model. The idea is that if you hide the complexity with good enough interface, simple enough and well-sealed interface, then this might be not a problem. But we started doing that, and we saw that we are not only leaking this complexity and putting even more complexity. We are started affecting C-star right now. We would need to address the gist. We would need to touch it. We would need to apply basically the same C-star shared pointer from C-star foreign pointer from C-star shared pointer pullable underscore FD also in this C-star. I guess it's not mergeable. I guess it's against what SkylaDB needs.
And that's why when Sage says something like, "Oh, we're just gonna redo it anyway," that's the claim that scares me. If we actually are like, if it's gonna be a big thing and like throughout the whole code base we've written, not a little thing, or rather not an isolated thing. But we're over on this meeting, guys. So
Yeah, I do
Thanks,
actually
Rad.
have to run pretty soon too.
We are.
And we're losing people. So good discussion. I'm gonna try to drag Kifu into this meeting again next week because he avoided me this morning, I think. But we'll continue to discuss the next week. Tushar will be you're back next week, right, Tushar?
Yeah, I'll be here. I'll be back. So
Okay,
Mark,
cool.
I also asked Yingshen to join, although it's kind of, I mean, both Kifu and Yingshen is pretty late, but I'll still ask him to join if I can. And Chunmei, or at least Chunmei from our US side, she's in Santa Clara, so she should be able to join.
Okay.
Yeah, because they've been hard at work, and I mean, I know they have a lot. They actually have code written right at this point, and I don't know, Radek, like how far a deviation is from what they already have versus what you're suggesting, right? I think that's something I need to understand, but yeah, we can talk about it, like either on the call. I believe it's tomorrow morning, Radek, your time. So late Thursday night or next week sometime. Yeah, we should talk about it before coming to this call. Yeah. All right. Okay, thanks.
All right. Well, sounds good, guys. Thanks for joining.
Yeah. Okay.
See you next week.
Yeah. Bye.
See you. Bye.
Thanks all.